Okay, so I will let Amit take us through the enterprise asset management suite, which is what we really want to discuss today. And this is really a platform, and and you will see from Amit presentation that we are unique in right now in the market with let's say advanced features. And I will let Amit present the RM Enterprise to us. Maybe he will go through to the demo directly, but I will let him decide. Thank you.
Thanks, Paul. Thanks a lot. Am I audible, Paul?
Yes, very well.
Okay. Let me share my screen. Can you guys see my screen?
Yes.
Okay. So first of all, good morning, everyone, or good afternoon. Uh, Paul has talked about so many products, so he has lots of products in his basket. Where the product which I'm going to talk now is how you can utilize the data from all those testing systems and monitoring system and get the information about your grid. So the software or this enterprise asset performance management software, what I am presenting today, it has the capability to collect data from different data sources. Those data sources could be testing equipment, whatever Paul has described previously. It could be a simple visual inspection report. It can be a legacy data you already have. For example, operating condition of the transformers, historical load profile of cable, historical load profile of transformers, then other real-time operating conditions like oil temperature, winding temperature, temperature of the cable, weather data. All this data can be collected into this system, and this data can be utilized in getting the information about the health of the electrical asset and the remaining life or residual life assessment. Okay, so if I talk about the software can be installed into customer data center, which we call it on-prem version, and software can also be installed into the cloud platform, either into your customer cloud or into the rugged monitoring cloud. So we provide all options, cloud-based solution. If customers are uh, looking for health assessment as a service, we can provide this as a service where all the data is stored into our cloud, and we are providing the health assessment service to our customer. Or we can also provide a on-prem solution to our customers where entire software is installed into customer premises or customer cloud, and they are owning the data, they are reviewing the data, and if they give us the access to their data, we can also provide the assessment to that data. Okay, and this system is multi-asset, multi-site, so it has a capability to perform the health assessment of multiple electrical asset and also from the multiple sites. So this is as soon as I log into the system, before I jump into the system, it is highly secured system. So we have certified this system with ISO 27001 and also IEC 62443 related compliance. So from the security perspective, this is a secure cyber security proof solution for our customers. So when I log into the system, in terms of login, it integrates with the Active Directory of the customer via a single sign-on mechanism. And when I log into the system, it shows me the complete network of the utility. So in this network, you can see if you have regional distributions. So it will show the health index of each region. If it is substation in a region, it will show the health index of each substation. And I can I can get into the detail by clicking into the map itself. So like here it is showing the zones, and if I click on the zones, then I'm into one zone, and here it is showing the power plant. If I click on the power plant, it will show me the substations and associated power plant. Okay. So I have the flexibility to go into the network or to traverse into the grid via the map view, or I have the flexibility to traverse using the right-hand side tree view. So if I click on the tree view, it shows me all the grid network configured for that particular customers. And if I click on any of the level, like at this level, it is showing me the company level view. And if I click on the any other level, it will show me other view. Currently, it is connected with the cloud platform, so probably I'm having some internet connectivity. But at the end of the day, this is how you can traverse. And then we have given some dashboards here on the right hand side. These dashboards here, it says that overall health of the all electrical assets connected to the system. So right now there are 76 assets connected. Out of 76 assets, 68 assets are very good conditions. 3 assets are into good condition, 4 assets into poor condition, and 1 asset into fair condition. So very quickly, I'll get to know out of all the assets that are configured into the system, what is their health, and then I will be more interested to see which are my poor asset. And basically what we have given is we have given the definition of very good, good, fair, poor, and unsafe. So ideally, I would be very much concerned about unsafe electrical asset. Next is poor and fair. And these are all index calculation. And then in the below, we have given the another user interface for showing the temporal distribution of these healthy assets. So over the time, whether my healthy assets are increasing or my poor assets are increasing. If my poor assets are increasing over the time, it means I need some intervention into my condition monitoring strategy or maintenance planning. If my healthy assets are increasing, it means my maintenance managers are working really well and my maintenance planning is working well. And if I click on poor electrical asset, it directly takes me to the poor electrical assets. In this case, right now, I have these 4 poor electrical assets. Out of these 4, 2 are towers and 2 are conductors. And if I click on the tower, it goes to the tower level view. And now I see the data related to this tower. And I see there are some hotspot detections and some ultrasound scanning has been done on the tower, and because of the ultrasound scanning, I have some problems. So all of uh, this is calculated from the offline testing data, visual inspection records, and online monitoring data. It does not mean that if you do not have online monitoring, it won't work. It will work if you just have the inspection data or simple photographic data, videographic data, so those kind of data. So we quickly looked into the tower. So an all electrical asset, if I want to have the planning for what transformer I should select for a maintenance or replacement in this year, next year, or next 5 years, we have given this view, categorical view of different assets, where we have categorized different assets into different asset class, like transformers, cables, motors, generators, switch gears, medium voltage switch gears, high voltage switch gears, AIS, GIS, bus duct, UPS. And as soon as I click on any of the asset class, it tells me all the assets that are configured into the systems. So like if I clicked on the transformers, so on the transformers, I have currently 36 transformers into this system. And if I see all the 36 transformer into one page, so I can see all the 36 transformers and their health index. And if I put the health index in a sorting manner, so higher the health index, more risky to operate the transformer. So if I put into the descending orders, the top at the top, I will see the transformers that are with the concerning health or that have worse health than the other transformers. So out of 36 transformers, you see that these four transformers, these power transformer 02, TR034, TR033, TR034 into another substation. So these transformers are into my amber zone, or these are not better than the other green transformers. So I'll be more interested to see what's happening in these four transformers. And if I click on the first transformers, then it takes me to the transformer level view. Then it tells me what's happening in this transformer. So at this level, when I clicked on all the transformers, I get to know which transformers are uh, more critical for me to look, or which transformer I should plan for my maintenance, or I should plan for further testing. Now, next level is telling me what kind of maintenance or what kind of testing needs to be done on that transformer. So here the health index is 2.1, criticality is 2. Criticality means the consequences of failure. So if a transformer has higher consequences of failure, so we give higher criticality, and pretty much, this is given by our customers like you guys. And then the risk index is a factor of health index, criticality index, and probability of failure. Okay, so based on this, it tells me what's the risk of operating these transformers. And if health index is going towards the poor direction, then what are the components that are responsible for this poor health? Whether it is a main tank problem, winding problem, OLTC problem, bushing problem, or oil problem. So quickly, if I look into this, it seems to be the oil problem. And then if we further detail into the oil health problem, it tells me whether it is a dielectric problem or thermal problem or oil quality related problem or some mechanical issue inside the transformer. So it seems that it has mostly thermal and oil quality related problems, and it has little bit of dielectric problems. So it's a combination of the problems. So combination of the problems will result into different kind of steps that utilities have to take the next. So, and we have also given the next step that utilities needs to take. So for example, okay, whether this transformer, do you need oil sampling in next 3 months, or do you need oil sampling in next 1 week, or do you need to install a DGS systems to get more data on a real time basis? So such kind of or do you need oil regeneration, or do you need some kind of oil change or some kind of other in interventions? So this kind of automatic recommendations are given by the system itself. So what I mentioned about giving you the overall picture of your electrical assets, telling you which assets should go for maintenance or further testing in this year versus next year versus 2 years versus 5 years, and then what kind of maintenance activities and or repair activities needs to be performed into those assets. So we provide you a complete workflow from the maintenance perspective, from the replacement perspective, and from the performance optimization perspective. So this is at a very high level, guys. Then we have, if you have transformer experts who want to see whether our data, whatever we are giving recommendations and our analysis is correct or not, for them we have given the industry standard analytics as well, like dual pentagon, dual triangles, IEC ratio, Roger ratio, and all of this is being done on offline data as well as online data. So if your transformer does not have online DGS systems, we can give this analysis based on your offline testing, oil sampling data. If it has DGA, then we can give both oil sampling result as well as the DGA result, and you can compare these things. So this is, again, this level of detail is mainly for your transformer expert or people who want to learn more about transformers faults. So here, if you see, some of the dual triangles are saying partial discharge related issues, which is basically dielectric issues. Some of the dual triangles are saying, DT is basically a combination of thermal and electrical fault, stray gases. So, and again, C is the hotspot. So here also, we are getting a mix of information. There is some dielectric issue, some thermal issue. So whatever our analysis has given is roughly the same as other industry standard analytics are telling. But again, these are just for confirmation whether our analytics has given the right kind of analysis or not. Then we have the DP calculation. So DP calculation is degree of polymerization, which is helping to understand the life of the paper in the transformer, and then helping to understand the residual life of the transformers and creating a business case for your asset maintenance, asset management team for replacement of the transformer. So we have again worked on different kind of degree of polymerization algorithm, and based on these different kind of DP analysis, we give our customers the value of the different, aging on the transformers and when the transformers needs to be replaced. So that kind of information is also provided. If you have information from your real-time sensors about oil temperature, ambient temperature data from weather information, winding temperature data from WTI, then the oil level data from liquid level indicators, we can collect all this data into the system, and not only collecting, we can give you the impact on the health of the transformer because of this data. Okay, then similarly, OLTC, bushings, capacitance, and 10 delta. Again, this capacitance and 10 delta does not need to be real-time data. It can be a offline testing data. And how you can store the offline testing data. So we have given a separate section for offline data input. So in this offline data input, we call it ODI. So in the ODI, we have given different options for entering different type of test results, like oil testing. So oil testing, we have given options for entering the oil testing results. So if I click on new, and if I select subsystem, which is like if it is a bushing oil or a main tank oil or OLTC oil, and if I click on the main tank oil, then I have options for entering the value of different kind of oil testing, or whether it is a dissolved gases or furan testing or oil quality related data. So all data entry is provided, data entry options are provided here. Okay. Now, many customers are telling me that, okay, this is too cumbersome to enter the data here manually. So what we have given is we have given a generative AI based tool that can read your oil testing result file, whether it is a PDF format or if it is a Excel format or any other format. It can read that file and it can enter the data automatically. Then the only work for you guys will be to verify whether the entered data is correct or not. And as soon as you verify that the entered data by the generative AI tool is correct, you can save the data, and then it automatically recalculates the health index of the transformers and gives you the impact of this testing on your transformer health. And the same thing is for Dharana testing, winding resistance testing, insulation resistance testing, turn ratio, all electrical testing on the transformers we have covered, electrical testing on the bushings, OLTC, all those testing has been covered. And as soon as the test results are entered, it updates the health index of your electrical asset. So the idea is all the high value data you guys are currently having, we utilize that data to give you the current status of your electrical asset. And based on your current status of electrical asset, we help you to work on your creating the maintenance plan. We help you to create the further testing plans, and we help you to create the replacement plan of your grid. Okay. And then also the same system can also be utilized to help you identifying the monitoring requirement of your electrical asset. So So take an example. I'm again taking an example of the transformers. If in one transformers, if the system tells you that you have to do the DGA testing every 2 months or every 1 month, so it makes sense to install the DGA rather than doing the oil sampling every 1 month. Okay, so that's how we are helping customers in their day-to-day operations related to the maintenance and also related to the planning. Okay, then if you have the visual inspection related activity, so take an example, you are sending your crews for visually inspecting the transformers, visually inspecting the cables, circuit breakers, cable terminations. We have given the interface for those engineers to directly enter the data here. So for example, what we do is we give a QR code against each asset, and whenever the service engineer goes on site, they scan the QR code, and based on the QR code scanning, it automatically opens up the visual inspection form for that particular asset. And as soon as it opens up the visual inspection forms, now the guy will have options for entering this data. And again, this template can be customized. Whatever I have shown you here, guys, this can be customized based on your requirement. So we can customize this. They enter the data. So if they are seeing any leakage, they can report any leakage. Let's say they report obvious leakage or heavy leakage. And then as soon as they save the information here, it automatically updates the health index of the transformer. The health index of the transformer gets updated, and then instantaneously the alarm or alert goes to the customer. There is a heavy leakage on the main tank. The health index has gone down, and then your maintenance team or responsible transformer manager talks to the inspection guy, service guy, asks for a photograph. The service guy clicks the photographs and uploads the photographs here, and then everything is done on near real time basis. So what we have done is we have created this platform for digitalizing your operations. First, we are digitizing your data. Then we are giving you a platform that will enable you in digitalizing your operations, whether it is testing operation, whether it is inspection operations, whether it is planning operations, whether it is any repair or maintenance operations. So this is the tool we have, guys. Today, I'm just focusing on transformer in the interest of time, but we have done the same thing for cables, same thing for GIS, AIS. So we have done similar kind of things for every electrical assets you guys are having, high value electrical assets, and this gives you the one platform for all electrical assets, all type of data, maintenance related data. Any question on this?